Hi, my name is Becky Adkins. For the past several decades, my research has focused on neonatal immunology. During that period of time, the field has acquired a great deal of information on the characteristics of the developing immune system. One of the principles that has emerged, I believe, is that there is great conservation of many of the properties of neonatal immune systems across different animal species. And this is true in addition for the organism that I work on, which is the mouse. So one of the things that has become apparent is that many of the properties of the neonatal immune system in the mouse are shared with those in human. So I believe that the mouse makes a good experimental model which is representative of what is happening in human development. Of course, in order for us to really understand the regulation of how these events occurs, it's important to be able to do experiments in vivo. This will allow us to directly test hypotheses about what regulates the immune system development. In order to do that, it's important to be able to manipulate neonatal animals. In fact, over the years, I've been asked several times for written protocols to describe some of the manipulation of neonatal mice. And of course, again, it's difficult to actually fully describe in words how one manipulates live animals. So we have put together this video to try to demonstrate several of the techniques that we use for manipulating murine neonates. My assistant will show you different ways of introducing materials into neonates by different routes, including intravenous, intraperitoneal, subcutaneous, and orogastric.
Before you begin, make sure the pups have milk in their stomachs and are warm to the touch. When ready, remove all pups from the dam and transfer to where the injections will take place. Keep the pups warm by providing a gentle heat source, such as that of a lamp. Gently pick up a pup and restrain it using your thumb and index finger. It is best to tuck its arm underneath as it can interfere with the injection. The vein is located at the corner of the eye and runs along the cheek towards the neck. Once restrained, bring the pup close to a heat source so that the vein can dilate. With a cotton-tipped applicator dipped in 95% ethanol, sterilize the area. Using a 1 cc syringe with a 30 gauge needle, inject a maximum of 50 microliters of your prepared solution. To do this, keep the needle bevel side up and introduce it parallel to the skin with a slight angle. The vein is just below the surface of the skin. Slowly dispense the contents of the syringe, carefully pulling out the needle, and immediately apply pressure at the site of injection to stop the bleeding. Once the bleeding has stopped, place a pup aside and keep warm. Figure 1 shows a representative experiment in which GFP-positive, CD4-positive donor cells were analyzed 1 week after IV injection of neonates. Donor cells in the lymph nodes were detected by flow cytometry. Similar proportions of donor cells were found in the mesenteric and peripheral lymph nodes, and the extent of chimerism was dependent on the number of donor cells injected. For intraperitoneal injections, restrain the pup by holding its head between your index and middle finger and its posterior legs between your thumb and ring finger. Inject the peritoneal cavity by introducing the needle, bevel side up, and parallel to the skin. Inject a maximum of 25 microliters of your immunogen. For subcutaneous injections, turn the pup over and restrain it between your index and thumb while it rests on your middle finger. Introduce the needle just below the surface of the skin between the shoulder blades at the base of the neck. Inject a maximum of 25 microliters. Proceed to the base of the tail and just below the surface of the skin, inject 25 microliters. Figure 2 shows a typical outcome to this approach. Neonates and adults were immunized sub-Q and IP with KLH. 1 week later, the frequencies of CD4-positive cells secreting IL-4 or interferon gamma were measured using a needle spot assay. Under these conditions, neonates and adults showed similar proportions of interferon gamma secreting cells. However, the frequency of IL-4 secretors was at least 5 times greater in neonates compared to adults. For this procedure, the pups are sedated with isoflurane. Restrain the pups by gently pinching the scruff of the neck. This pulls back the anterior legs and straightens the esophagus. Then hold the pup upright. To ensure the pups are properly sedated, gently pinch their paw for signs of sensitivity. No movement is a sign of proper sedation, and you may continue with the procedure. Begin by placing the tubing into the pup's mouth and guide the open end to the back of the throat. Then slowly move the tubing to either side of the mouth. Apply gentle pressure. As the pup gags, slowly slide the tubing down the esophagus. There should be little to no resistance. You want 3/4 of an inch of tubing down the esophagus so that your solution is injected directly into the stomach. Slowly inject a maximum of 25 microliters. Here we have used HPSS with 1% blue food coloring. This allows us to visualize the success of the procedure as the stomach contents turns blue. Once done, slowly remove the tubing and keep the pup upright for a few seconds to ensure all the solution is kept down. Return the pup to the dam. Monitor the pups for signs that the anesthetic has worn off and that the dam is nursing them. Figure 3 demonstrates inflammation in the mesenteric lymph nodes following orogastric infection of neonates and adults with the gastroenteric pathogen, Yersinia enterocolitica. 3 days after infection, the frequencies of cells with the neutrophil phenotype LY6G positive, CD11B positive were monitored by flow cytometry. A typical fluorescence profile is shown in Figure 3A, and the frequencies of individual animals are depicted in Figure 3B.
These approaches can be used to study, for example, vaccine responses, responses to infectious agents, or even to introduce eukaryotic cells of your choice. So we hope that these video demonstrations will help you to establish these techniques in your lab and allow you to enter the fascinating field of developmental immunology.